Hi there, this is your favorite non-Indian math channel, and I have a pretty interesting looking summation problem for you. So let's see how we can do it. So first of all, about this notation, this is floor function, which can also be called integer function, and it is gonna give you the integer part of a number. Okay, for example, if I have a number x, and if I take floor function of it, it's gonna give me a number that is at least n. Okay, and at most n plus 1. Well, it's not going to be n plus 1. And so we are picking biggest such n. For example, if I had 1 over 2, 1.2, this would be equal to 1 because it's the number. And if it was 1, this would still be 1. And if it's minus 1, and if it's, for example, minus 1.2, this may be a bit tricky, but it's minus 2. Okay. And so let's see how we can do it. So I have arctangent of n squared, which is pretty ridiculous. And for this part, so I have something here, and this may be maybe something simple. It can be 1 if you're lucky, or even 0. If you're lucky, this can actually be 0, and then our just summation would be 0. So let's see. I have ln n over n minus ln n. And if I look at bound, if I just compare n and ln n, n is much bigger than ln n. So I would guess that this thing is just positive, and this thing is probably less than this thing. So I may guess that this ln n over n minus ln n, this may be between 1 and 0. So if I can show this is true, then if I take floor function of it, so this is going to give me 0. And now, so let's see how can I do it. We can begin with any part. So let's begin with this part. Or let's begin with other part, because this seems a bit easier. So I'm starting my n's from 2. So ln2 is just positive. So this part is positive. And what about this part? So if I can show that n minus ln n is greater than 0, then this, let's call this whole expression a, okay? So if n minus ln n is also positive, so this a is going to be positive. So how can I show that? Well, I can just send this ln n to the other side. So this is going to be true if and only if n is bigger than ln n. And this is going to be true if and only if. So I'm just going to take e to the power of both sides, and I know that e to the x is increasing function. So if I take e to the power of both sides on an inequality, the inequality won't change. So I'm going to have e to the n is bigger than, so e to the ln n is just going to be n. And here, if I think e to the n, I know that it's even e to the x is even bigger than 1 plus x for each x, and 1 plus x is of course bigger than x. So I can say e to the n is just bigger than n. This is always true. So this is true. If this is true, so I have if and only ifs here. So this is true. So this is true. So this a is bigger than 0. Okay, so this is our first part. But I will make a bit more reasonable excuse for this at the second part. So now I want to show my second part, ln n over n minus ln n is less than 1. So let's see if this is true. So I already showed that n minus ln n is positive. So if I just multiply both sides by n minus ln n, the inequality won't change signs because it's positive. So ln n is less than n minus ln n. Here my logic is that I'm just doing if and only if steps, but of course it should be an irreversible step. And in the end, I will try to find something simpler. For example, you could, like, if you want to impress someone, you could just start from here. I have e to the n is bigger than n. This is true. So I can just take log of both sides, okay? And then you could say, okay, I'm going to send this ln n to on the left side. So this is true, but this is valid, okay? And yeah, this is the easiest way to write it. Or you could just, after you've written it, you can just delete the beginning and just pretend like you found it from scratch. So how can I do it? I want to show ln is less than n minus ln. So if I just add ln to both sides, 2 ln is less than n, and 2 ln is just equal to ln n squared is less than n. And now if I just again take e to the power of both sides, it's gonna be n squared is less than e to the n. So also if you look here, I kind of accepted that e to the n is bigger than n, and now I have e to the n is bigger than n squared, and since I know that n is bigger than 2 on this problem, we can also say it's just bigger than 1. So this is also bigger than n, and if I actually show this, I can also have another reason that this left side is true. Okay, so my goal is to show that e to the n is greater than n squared. Then my question will be done. I already showed a is positive, and now I'm trying to show a is less than 1. So my goal is to show for each n is greater or equal than 2, e to the n is greater than n squared. So let's define a function. It's easier to show e to the n minus n squared is greater than 0. There are multiple ways to prove this. Okay, I will pick an easy method. So I'm going to define a function. If I can show this is true for each x greater or equal than 2, it's going to be true for integers n too. So I'm going to define a function e to the x minus x squared, because I want to use derivatives and I can take derivatives of sequences. And now I'm going to show this function is positive. So what can I do? I can just use derivative tests. So I can take derivative f prime x, and if I take derivative of it, it's going to be e to the x minus 2x. So do I know this is positive? Well, not exactly. It would just be cheating. So how can I do? I can take one more derivative, and this is going to be e to the x minus 2. Okay, here, so I know that x is, so I said that n is greater or equal than 2, so x is also greater or equal than 2. Okay, I'm just dealing with this part. Like, it doesn't have to be true for each x. And so here, I know that e is approximately 2.718. So even if I put x is equal to 1, this thing is positive. If I put x is equal to 2, this thing is still positive, and e to the x is increasing. So this thing will always be true. So what this means, that e to the x minus 2 is positive. So f2 prime is greater than 0. This means that the one, if I take just, how did I come to f2 prime x? From f prime x. So this means that f prime x is increasing. Okay, from here I can say f prime x is increasing on this interval. Okay, we're one step closer. So if I know that f prime x is increasing and my lowest bound is just 2, instead of x, if I just put 2, I could even show it for x is equal to 1. It would be slightly easier, but let's go with 2. So I'm writing f prime x e to the x minus 2x. So if I know that this function is increasing when x is greater or equal than 2, then this function is just going to be greater or equal than f2, because every value bigger than 2 is bigger than that. Okay, so 2 is, like, f2 is lowest value of fx. Sorry, this is f prime 2. So f prime 2 is just going to be, so I'm putting x is equal to 2. Let's say e squared minus 2 times 2. So this is 2 times 2, and this is something bigger than something. So this is obviously e is bigger than 2. So e is bigger than 2, then e squared is just bigger than 2 times 2. So this thing is, of course, positive. So what I found is that f prime x is positive. So this means that fx is increasing. Well, it's probably not the shortest way, but it's pretty clear, I believe. So if fx is increasing, again with same logic, I can say that fx, for each x greater or equal than 2, fx is greater or equal than f2. So what this means is that fx is equal to e to the x minus x squared is greater or equal than, so f2, I'm just gonna put again 2, and I will actually get the same thing because it's again same. So it's gonna be e to the 2 minus, again, it's just 2 times 2. And I literally, with same reason, this is gonna be greater than 0. And therefore, I can say fx is positive. Okay, cool. So I actually finished this. So I showed that this is true for just when n's are greater or equal than 2. And therefore, I can just finish my question actually. So let's see. I showed that this a, here I like showed it with a for simplification, and I found that this thing is between 0 and 1. So like I said, like how I introduce you like floor function, if something is between 0 and 1, floor function of it is just gonna give you 0. Okay, and therefore this thing is equal to 0. So therefore, it's just going to be arctangent n squared times 0. For each term is just going to be 0. Therefore, our sum is going to be equal to 0. And this is our answer.